2. Jumping right in. Use synthetic division to divide f of x by x minus 3. Write a summary statement in fraction form. Okay, guys. I start with a box to represent what I'm dividing by. Do we remember what goes in the box?
3. Negative 3.
Which is it?
Negative 3. X minus 3. 3.
Because you're like, mine is you have to go.
Okay. So.
I couldn't remember, so. Come on, guys.
Yep. Okay, x minus 3, guys. We're dividing by that factor. What value represents that factor? And keep in mind, this is of the form x minus, I think k is what my other book says. Okay, so how is x minus 3? That's going to be a regular 3. It's always opposite the sign of the factor. Okay? Now, next to this, remember you just do your row of coefficients, making sure you put zeros in place of any missing values, right? So, x cubed is my first term. I'm going to write down 2. What comes after an x cubed term? An x squared term. My coefficient is negative 3. What comes after an x squared term? An x term. My coefficient is negative 5. What comes after an x term? A constant term, or an x to the 0 term. Okay, so that's just my list of coefficients. I didn't put zeros in any place because I didn't have any missing place values, right? We talked about that yesterday. Leave a room for a line of work, for a line of numbers, and draw a number, or draw a line. Okay, first thing we do is we drop that 2. Okay, we're going to drop that 2. And then we're going to multiply. So you're always using this 3. I'm going to do 3 times 2, which is 6. That's going to go in your next column, and you're going to bounce it back up above the line. Then after we multiply, we're going to add. This is and that's the thing. This is different from long division, right? So it's multiply and add. Multiply, add. Multiply, add. Negative 3 plus 6 is 3. So that I don't usually put the add sign in there, but that's what we're doing. Then repeat the process. Always go back to this 3 here. Multiply. 3 times 3 is 9. Add. Negative 5 plus 9 is 4. Multiply. 3 times 4 is 12. Add. Negative 12 plus 12 is 0. What is that 0? The remainder. Okay, that is your remainder. How do we express our answer?
(2x squared plus minus something 3x. Some sign 3x, some sign 4. 2x squared plus 3x.
Use the provided signs, which if there's nothing there, it's positive. If we want minus, these would be negative terms. Okay. Now, I do have, it says write a summary statement in fraction form. Braden just listed off the answer, so to speak. A summary statement in fraction form is just kind of stating, okay, what was the original problem? So the original problem was 2x cubed minus 3x squared minus 5x minus 12 divided by x minus 3. That's the math we just did, yes. Equals 2x squared plus 3x plus 4. That whole thing there is officially your summary statement. In all honesty, though, what's the answer? The 2x squared plus 3x plus 4. We could write a remainder the same way we did yesterday. I didn't mention it. Braden just started it. Why did he Why did he make this 2x squared?
Because there's no. I really don't know.
There were 3. Oh, you just went down one.
Yeah, it was x cubed to begin with. And if it's x cubed to begin with and you divide by an x to the first, you're always going to go down 1 power. So if your original problem involves x cubed, your answer is going to start with x squared. It's always just down 1 power. Is this all sounding familiar?
Yeah.
Or doable. Maybe I should put it that way.
Yeah.
Irrelevant if you don't remember what I taught you exactly a year ago, but you know. Okay, so there is your synthetic division. We're going to practice more synthetic division. As we go in and practice the synthetic division, it's, you know, the whole idea is going to be figuring out remainders. Okay, so our focus today is rational roots theorem. Okay, so Algebra 2, you got a nice easy lesson about synthetic division. We're jumping right in. We're going to use synthetic division today, okay? So rational roots theorem says, suppose f is a polynomial of degree 1 or larger, then, and they give this as x equals p over q. If x equals p over q, where p is a factor of the constant coefficient, and q is a factor of the leading coefficient. Okay, so we're going to be able to, x equals p over q is a factor if p and q have those pieces. I'm really butchering saying that. Yeah, so if f is a polynomial of degree 1 or larger, x equals p over q is a factor. I feel like I don't have this typed out right, in all honesty, because I feel like it's like not a complete sentence. P is an integer factor of the constant coefficient. Q is an integer factor of the leading coefficient. I guess it's just saying x equals, so a root, a solution is. Okay? So, now, in all honesty, I don't know if this is sounding familiar yet, but we did do this last year. Okay? I haven't quite taught it in Algebra 2, but that's coming up next week. Okay, so we did do this. Do you guys remember talking about PRRs?
Yeah.
Possible rational roots?
Oh,
Or
yeah.
potential rational roots?
Mhm.
That's what this is. That's what this P over Q is. Okay? Now, you guys are giving me crazy looks, so let's just go through it and do an example. Okay?
Please and thank you.
Okay, now, do notice we have 3 questions here, right?
Yeah.
Example 2 says find the rational zeros. Example 3 says find the rational zeros. Example 4 says find all of the zeros. So keep that in mind. That means I'll want rational, irrational. I don't think we talk imaginary today.
In between, right?
Imaginary's next lesson. Okay, we'll do that. We'll do that after the quiz next week. So, what? We're due for a quiz next week. We're halfway through.
Already?
Okay.
We're flying through this.
Okay. We want to find rational zeros. We're going to start with what I'm going to call PRRs, which are possible or potential rational roots. Okay? Now, in order to do that, this is where we're going to do the x equals p over q. When I talk about x equals p over q, what did it say? P is an integer factor of the constant. What is my constant in this problem?
4.
4. Bless you. So 4 is my constant. So that means on top here where it says P, we're going to be looking at what are my factors of 4 over Q. What's it say Q is? Q is an integer factor of the leading coefficient. What is my leading coefficient?
1.
1. The invisible 1 here. So this is my leading coefficient. So we're going to be dividing by factors of 1. Is this looking at all familiar to those of you that are back again?
Yeah.
Okay, it should be.
Like cancel.
Okay. What are my factors of 4?
2, 2, 2, 4, 1,
1. Yeah.
1, 4.
So 1, 2, 4.
Okay, so 1 and 4, 2 and 2. When I list this, I'm going to list 1, 2, and 4. Now, integer factors means we're not just talking about the positives, we're also including the negatives. So I'm going to list this as plus or minus 1, plus or minus 2, and plus or minus 4. So always plus or minus. What are factors of 1?
1.
Plus or
Plus
minus
or minus 1.
Plus or minus 1. Yes, Addie?
For the 4s, where do you get the 2?
Where did I get the 2?
Yeah.
Because 2 times 2 is 4.
Oh.
So like the idea, when we talk about factors of 4, it's 1 times 4, and then it's 2 times 2. So I don't need to write 2 and 2, but does that answer it?
Yeah.
Okay. Now, I don't leave this just like this though.
cancel the 1s.
I wouldn't use the word cancel.
Don't you have to write it out so you can do -1, -2?
We're going to make a list. And the idea is that everything in the numerator has to take a turn over everything in the denominator. Now, my denominator is just 1. So what's 1 over 1?
1.
Plus or minus 1. What's 2 over 1?
Minus 2.
2. What's 4 over 1?
Minus 4.
And then do I have anything else?
No.
No. If I had another denominator, I'd take turns putting them all over that other denominator. So my possible rational roots are plus or minus 1, plus or minus 2, and plus or minus 4. Okay? So these are what I call my PRRs. And I guess I should have warned you, I have a lot to put in this box, so yeah. Hopefully you can tell I'm trying to write small. I'm warning you, I have a lot to show here. Okay, those are my PRRs. And I guess I did write it here in my notes, so I'll put it over here. That these are my potential rational roots. Or if you, instead of potential, you prefer possible. Okay, that's what PRR stands for. Does that mean they're all going to be roots of this equation? No, they just can be, okay? There's not going to be 6 solutions to this equation, right? How many solutions at most could there be to this equation? It is a degree 3, so at most there's going to be 3 that work. Now, okay, there's a couple different ways we could proceed from here. We need to figure out which of these 6 work. Now, the name of the game today is synthetic division. An option is to take each of these and try synthetic division. Not the option I'm going with, but that's the idea. Because now, when I say synthetic division, we're going to use synthetic division. How do we know if one of these works? The remainder is 0, because yesterday the factor theorem says something is a factor if the remainder is 0. So that's how we're going to know if something works. Now, okay, we're going to be smart about our lives here. We don't want to test all 6. I'm nice and I say, take a peek at the graph. And use the graph to give you a starting spot as to where should I check one. Now, in all honesty, if they're whole numbers like these, okay, you're kind of just going to be able to tell all of them. But that's not always the case. Okay, so throw this equation in the graph. Sorry, I guess I should have said, you need calculators today too. And in all honesty, this problem wouldn't be horrible if you just started guessing.
Heck within my
Now, here's the deal. Okay. I absolutely do not want you finding zeros on that calculator. Graph it, look at the graph, that's all we're going to do. We're not going to do anything else with the calculator. Does that make sense?
Mhm.
Okay, so we're not trying to find all those zeros on the calculator. We're going to use the paper and pencil method to verify what they are and how this factors down. Okay? Now, what I will say though, based on the graph of my choices, plus or minus 1, 2, and 4, what would you suggest we try?
2.
Does 2 look like it's going to work?
+2. Yes.
Okay, a positive 2 looks like it's going to work. So, and I was just, again, I'm just trying to give you guys notes. How far do I, okay. So it looks like something goes through 2. Looks like something goes through between 0 and -1. And it looks like something goes through past, just past 6. Okay, so if I just put okay, so that's just, I'm just showing that because this, so now what I'm going to say is based on the graph, and you wouldn't necessarily have to put this part down on your paper, we're going to try x equals 2. Fair enough? Okay, so based on the graph, we're going to try x equals 2. And this is important because as we get farther into this, you'll need to be able to set this method up. And again, we're not gleaning everything from there. Now, when I say try x equals 2, what are we going to try it with? We're going to try it with synthetic division. Okay? Now, this is not a factor form, is it? This is x equals 2. So what goes in my box?
2.
That same number. You don't change the sign, you just put that same number in there. So we're going to try x equals 2. What goes across my line then?
1, -8, and 4.
He's got it. 1, -8, 10, and 4. Synthetic division, what we just talked about, yes? Drop the 1, and then we multiply. 2 times 1 is 2. Add, -8 plus 2 is?
-6.
Multiply. 2 times -6. Add. 10 plus -12. Multiply. 2 times -2. Add. 4 plus 4 equals 0. Okay, guys. What does that tell me? It is a factor. It worked because there's a remainder of 0. Now, after looking at that graph, I'll be honest. I'd be shocked if 2 didn't work. Okay? If 2 doesn't work and it really looks like it should work in my graph, I'd check 2 things. Check your math. Check your typing in the graph.
So
Somewhere there might be a mistake.
it works if it ends with 0.
Yes, because that means the remainder is
0.
0. Yes?
Gotcha.
That's why it works, because the remainder is 0. Now, with that in mind, what does 1, -6, -2 represent?
1x squared -6x -2.
Yes? Because it started with an x cubed, so this is x squared minus 6x minus 2. Okay, guys. Where we're using this synthetic division is we're using it to factor. What we have right now, f of x, okay, our original function, it factors down in 2. Okay, what was my first 0 there? My 0 was 2. What is 2 represented as a factor? X minus 2. Okay. We divided by x minus 2 using synthetic division. We got a remainder of 0, which means what's my other factor? what he said. Okay, x squared minus 6x minus 2. Now, we know we have a solution here with x equals 2, yes? Okay, we know that. X squared minus 6x minus 2. Does this factor?
Yeah. Wait. Maybe.
If it factors, you need numbers that what? Multiply to be negative 2 and add to be negative 6. It doesn't factor. Now, I'm not surprised. Because if it factored, it needed factored into this plus or minus 1, 2, and 4 business. And guess what? Keep pointing at the graph that turned off. But did it look like plus any of the other numbers were going to work? No. Okay, guys. What that means, you find those other two. They're decimals. What they are is they are the irrational roots. They're real because I can see them, but they're irrational. My directions ask me to find rational. So the only answer I need here, but what is that? It's, as a solution, it's x equals 2. This one right here does not factor. Okay. Now, because it does not factor, it means one of two things. It's either 2 irrational roots or 2 imaginary roots. Based on the fact that I can see 2 more roots on my calculator, it means there are 2 irrational roots. And in all honesty, we're not talking about imaginary roots today, officially. That's the next lesson, okay? But I'm bringing it up because it ties in. Okay. Practice is going to make this better because we've got 2 more to practice with. But questions I need to answer right now.
You said if it doesn't factor, it's either going to be irrational roots or imaginary.
Imaginary. Because this could, we plug it into a quadratic formula. It could give me plus or minus like a square root of 3 or something that we don't know. Or it could give me like plus or minus the square root of like a negative 3, which means it becomes i's.
So
Okay.
is that like why on the bottom one it says all real zeros? So is that where in that case scenario you would say both?
You would give rational and irrational, but not any imaginary. Okay, are we ready for example 3? Okay, let's move. Example 3. Notice my directions again. Say find the rational zeros. I need to see on your paper that you are starting with what today?
PRR.
PRRs, potential rational roots. Now, officially, potential rational roots, it's from that theorem up there where it says x equals p over q. Whether you write the p or q, I don't care. On top, factors of what on top?
2.
Officially, I should say factors of negative 2. In all honesty, is it going to matter?
No.
No. So it's factors of negative 2 because it was factors of the constant. Divided by factors of what?
3.
Why 3?
Leading coefficient.
Because that is the lead coefficient. Okay? Okay, we get to have more fun with this one.
Plus or minus 1 plus or minus.
Okay, and I made us put in the negative 2 because officially it is a negative 2, right? But in all honesty, factors of negative 2, factors of 2, how do you multiply to get 2?
1, 2.
1 times 2. Any other way?
Nope.
No. So we're going to say plus or minus 1 plus or minus 2. Factors of 3. How do we multiply to get 3?
Plus or minus 1 plus or minus 3.
1 times 3, yes? Nothing exciting here. Now, be careful with your list. There's a little bit more to the list this time, right?
Yeah.
Every numerator over every denominator. So I'm going to start by putting everybody over 1. 1 over 1 is 1. 2 over 1 is
2.
2. Now I've put everybody on top over 1. Now everybody on top has to go over 3. So plus or minus 1 over 3 plus or minus 2 over 3. Did I get everybody?
Yes.
Okay, are we good with how we get that list?
Yeah.
I know technically that's review, but you know, it's been a year. These are my PRRs, the possible rational roots. Are all 8 of those going to work?
No.
No. At most, how many are going to work?
3.
High power of 3. At most, this problem has 3 solutions. Okay? Now what? What one do you want to try? How am I deciding what one I want to try?
The graph.
The graph.
Yep. So we're typing in
-2.
I don't. Wait, what did I do? Oh man, I put in the last one again on accident.
It's okay, Brett.
Oh, I think I know which one I want to try.
Which one is it?
Well, actually, there's 2. What?
We
Yeah.
can try 1 or we can try -2.
Yeah, that's fine.
Alright.
Okay. So, based on looking at the graph, and again, we're not finding these zeros on our graph. We're just using this for eyeball. We're making our life easier. Officially, I should tell you, start trying to find something that works. That's officially what I should tell you. That's a lot more hassle than it's worth. Okay? So, on our graph, it kind of looks like maybe a -2 works. Kind of looks like maybe a 1 works. Now,
I say 1/3 might work.
what are we thinking about that guy?
Could be
1/3.
1/3.
Okay, that's kind of like a double question mark to me. Like, I really am not sure about that one. But here's what I'm going to tell you. Irrationals come in pairs. We said there's going to be at most how many answers?
3.
3. Well, if 1 and -2 work, that other guy has to be rational. Because there's not something else to pair with it, exactly. Am I making sense there?
So 1/3's not gonna work.
Or what if they all work?
Well, so that's the idea, is that it's looking like if 1 and -2 works, this has to be either the -1/3 or -2/3. Which, eyeballing it up there on the graph, looks like
1/3.
maybe the -1/3. Now, here's the deal. Am I going to try -1/3 first?
No.
No, for 2 reasons. 1, it's a fraction. But 2, it's my one I'm least confident about. So I'm going to say, based on the graph, I'm going to try x equals -2, 1, and maybe -1/3. Depending on what goes down. Now, in all honesty, here's the deal. We're not going to have to try all 3 because we're going to get done before we get to that 3rd one. But we'll be able to confirm whether or not it works. So, where would you like to begin?
-2.
Either -2 or 1 because I'm pretty confident.
I
Yes?
say 1 because it's easier to multiply.
I do agree.
Dang, she took notes.
Here's the deal. Be daring. Try 1 and then I'll give you directions as to what to do next. Because here's the deal. We're going to end up trying both. But don't jump ahead of me though. Okay? So we're going to end up trying both. So if you want to try 1, You can make that happen. Okay, what goes next to whatever number you're trying?
The 3, 4, negative 5, negative 2.
Okay. Whether you're trying -2 or 1, your first step is to drop the 3, yes?
Yeah.
And then we're going to multiply. Mine, -2 times 3 is -6. Add,
Negative 2.
multiply.
4.
Add,
Negative 1.
multiply.
2.
Add.
0.
And? Did it work?
Yeah.
Yes. Did anyone happen to try 1?
Yeah.
Did it work?
Me, Brain.
I did.
Okay, hold that thought. Don't go to the next step yet.
Okay.
No one goes to the next step yet, or you're going to mess things up. Okay? I'm trying to be truthful with you here, okay?
Okay if we did both.
It's okay, but you're still going to have to redo one of them. You can't do both on the original equation, or you're not going to get to the end.
Okay.
Oh, you have to do it on the equation that you make out of that.
Oh.
Oh my
Does
god.
this sound familiar from last
Came
year?
back. It just, it was
Just all
like,
of a sudden.
it was like, whoa.
Okay.
Back.
So here's the deal. Yes, you can do -2 and 1 both on the original, but you're not getting the necessary information. Say we have irrational or imaginary roots. We need to factor it down, and we're not getting that necessary information. Okay, some of you, it's starting to come back. Okay, so here's the deal. I do want to try 1 next, but this time, instead of using the original problem,
Use 3, negative 2, and 1.
you use whatever you factored down. Now, if you used 1, do those numbers make you look different?
Yeah.
Yes, but you use your new numbers
Uh-huh.
with -2 now.
So we're gonna take our new numbers and divide that by -2.
Right. And here's the deal. We're gonna meet. Our numbers are gonna match at the end of this one.
Hopefully.
Well, barring no mistakes on either side. So now I'm gonna try 1. We're gonna put these numbers up here. So 3, -2, -1. I'm dropping 3. I'm multiplying. 1 times 3. I'm adding. -2 plus 3 is 1. 1 times 1 is 1. -1 plus 1 is 0.
Awesome.
Yep.
Matched up.
Did we all match up at 3, 1, 0?
Yes.
Okay, so it helps if you take a buddy with you, right?
Yeah.
Okay, so -2 and 1, they both work. Thus, the plain graph that I keep pointing at, it works. Now, here's the deal. Officially, we have one more to, air quote, try, but we don't need to try it. Because, what does that 3 and 1 represent right there?
3x plus 1.
If I take that factor of 3x plus 1 and set it equal to 0, guess what?
It's -1/3.
Shocker.
That's crazy.
3x equals -1, x equals -1/3. Now, could you do synthetic division with it? You could. I know you're thinking, oh, fraction ugly, but it works out pretty. Okay. So here's the deal. That's my third. Now, what did they ask me to do? Find the rational zeros. What are my zeros?
X equals -2, 1, -1.
Okay. Could you write this in factored form if you had to? That's one of the benefits of synthetic division, folks. We just factored. We factored this into, we divided by -2, so a factor would be x plus 2. We divided it by 1, so a factor would be x minus 1. And we didn't divide it by -1/3, but that factor was 3x plus 1. Okay, it didn't ask me for factors, it asked me for the zeros. Okay, we gotta move. Example 4. What's the difference? All. Here's the deal. We're gonna have some irrationals here. What's gonna matter is how we treat it at the end. So, I'm gonna try and go quickly so we can get to the end. So I may not write everything. Can you handle that?
Yeah.
PRRs on top. Factors of 8 over factors of,
2.
are you guys okay with Brody's answers there? So what are factors of 8?
Plus minus 1, plus minus 2, plus minus 4, plus minus
What are factors of 2? Okay, are we pros at that like Brody?
Yes.
8, right? How was 8? 1 times 8 is 8. 2 times 4 is 8, right? That's where all those numbers came from. Now, everybody goes over 1, which means 1 over 1, 2 over 1, 4 over 1, and 8 over 1. So I just wrote down plus or minus 1, 2, 4, and 8.
Yeah.
I'm speedy, aren't I? Now, okay, I'm going to slow for a moment. Everybody goes over 2. 1 over 2.
1/2.
Plus or minus 1/2. 2 over 2.
Plus or minus 1.
Plus or minus 1, we already got it. Don't write again. 4 over 2.
2.
Already got it.
Plus or minus 2, we already got it. 8 over 2.
Already got it.
Plus or minus 4, we already got it. Do I need to rewrite things doubly?
Nope.
No, but you need to check everybody.
Nope.
So these right here are my
Yeah.
PRRs. Only 10 of them. Do you want to check all 10?
No, we want to graph.
No, we want to graph and pick these smart ones.
Oh.
Oh man. Oh, I think it was EV6 or something like here. And just weed it.
Oh, crap.
What?
Okay, yeah.
Looks like we need
I got scared that I graphed something wrong.
It looks like the X to the 4.
The only one I think of.
Hey, guess what?
Oh, shoot.
It is x to the 4th. How many solutions do you see?
4.
4. Okay, so again, I'm going to sketch the graph in my notes here. What are we thinking here?
Try 4.
Okay, he says try 4.
Makes sense to me.
Huh?
It's the only one that really is sticking out to me. Wait, no. And minus 1/2.
Now, this is a very rough graph. We're just going with it. I'm trying to hustle here, guys.
It works.
Okay. It looks like 4. It looks like maybe that could be a negative 1/2, couldn't it? These other 2? They don't fit my list.
They're irrational.
Okay. So we're going to try x equals 4 first. Then if that works, we'll try x equals negative 1/2. And that's all I have to try for my list, isn't it?
Yeah.
I don't have anybody else to try for my list. So, okay. Did you try 4? Someone said it worked. 4 in my box. 2. Negative 7. Negative 8. 14. And 8. Drop the 2. 4 times 2 is 8. Add. Negative 7 plus 8 is 1. 4 times 1 is 4. Negative 8 plus 4? Negative 4. Multiply. Add. Multiply. Okay. It worked. Now, you need to try the negative 1/2, even if you're saying no. Okay, I promise the fractions aren't horrible here. So negative 1/2 goes in my box. What are you trying with negative 1/2?
2, 1, negative 4, negative 2.
You have to use those new numbers. This is where you have to. Or you are not going to get your final answers. Okay. Drop my 2. Negative 1/2 of 2, negative 1. 1 plus negative 1.
0.
Negative 1/2 times 0. 0. Add. Negative 4. Negative 1/2 times negative 4. Positive 2. I got a 0. Are we okay?
Yeah.
They worked. Now, okay, here's the deal, guys. This is what you need. We have to know, what does 2, 0, negative 4 represent?
2 squared plus.
Mhm.
Would it just be 2 squared minus 14 minus 4.
Okay, I just kind of wrote in. This originally was x to the fourth. We divided the first time, this becomes x to the third. This is x to the third now. So now this is x to the second, right? 2x squared minus 4 equals 0. Solve it. 2x squared equals 4. X squared equals 2. And then if you square root, and plus or minus the square root of 2. So, my answers. The 4 worked. It was rational. The negative 1/2 worked. It was rational. They make fractions. And then we just found square root of 2 and negative square root of 2. That work. Guess what, guys? If I use my calculator and actually find those zeros up there, those zeros are going to be 1.414 and negative 1.414. Now, I'm going to know you cheated if you put 1.4 and 1.41, or put the decimal on, because what do I want?
Fractions,
The
right?
square roots and the fractions. Okay? I mean, 1/2, you guys can convert that easily, but do you know 1.414 is the square root of 2? I don't know. Okay, guys, I got the notes barely. Finish the homework for Monday. This is a new set of homework problems, right?
Yeah.
These are not the same ones. So you got yesterday's, you got today's. Put it all together. We'll check Monday. Thank you. Goodbye. Have a good weekend.
I like synthetic division. It's easier.
We checked that. We just didn't get to homework questions.
Have a good weekend.
Thank you. You too.
Thanks.